We have a very special episode today, a must-watch for all Tesla investors. Well, you're going to learn everything you ever wanted to know about Tesla's Cybercab, but was afraid to ask. Except you don't need to be afraid to ask, because today we have as our special guest Brian White, the single best Tesla retail analyst out there who knows the most about the Cybercab. How does he know so much? Because last week he had the chance to speak directly with several of the Tesla engineers who actually are responsible for designing the vehicle. Today, Brian will share everything from why they chose to design the doors to be butterfly wings, the size of the vehicle, secrets like what batteries it will use, which factories it will be made, what is the top speed, and more. And he will show you today that it's not going to be human driven at all. Tesla had a special invite-only event, and Brian drove 15 hours to get there and another 15 hours to get back home. That is dedication. But we are so fortunate he did that because no one else would know what to ask. We got Brian White here with us. He's his own host of his YouTube channel called Futuraza. And for this series of Cybercab, he has dropped 4 videos, and every one of them is chock full of information. Welcome, Brian.
It's great to be here. Slight correction. It was more like 14 hours each way instead of 15. But, you know, the thing is I had a chance to do a 5-hour total round trip to see it behind the rope, or a total of, 28 hours of driving to talk to the engineers and get inside. And there is no debate about which one of those is more valuable. So I had to do it.
You had to do it. And I was just saying earlier that a lot of people were there. Oh, I mean, it was invite only, so not everybody was there. But my point is that a lot of people were there who just did not ask the right questions. And you were asking multiple engineers. And this is how you've got this, you were able to do 4 shows because there's so much information. This is by far the most comprehensive review of the Cybercab we will ever get. And you answered a lot of questions. So let's get going here. So first of all, I just wanted to show people that this is the event. So you were at this event.
I'll let you know kind of some of the cool stuff that I'm working on with it.
And what we're listening to right now,
I'm going to introduce the team that I have here with me.
Who responsible for
you might know Wes. Wes is the engineering lead for the Cybertruck. So if you have questions about Cybertruck, we'll be able to answer that for you tonight as well. He's also director of vehicle tests, so there's a lot of good stuff going on there with Cybertruck as well as on the Cybercab. So Victor here is the lead program manager for Cybercab. So he'll answer a lot of questions about the product and some of the product strategies we have going forward. Z is one of our leads for body structures. So he'll give you both an insight into the body, unboxed, some of our manufacturing methods and some of the cool things we're doing there. Alex, he's our master of doors. Doors are really cool. So if you have questions on doors, definitely hook Alex today. And Mitchell is our lead for vehicle integration on the program. So obviously Tesla is very well done for vertical integration of the systems as well as the integration of systems in the car. So, he'll be able to obviously give you a tour of some of that cool stuff we're doing. I am the engineering lead for Cybercab and also handling the strategic launch of the product as well. So I'll take as many questions as I can as well today. Let's go over the concept of cleaning. It's also on the concept of reliability and service as well. The 2 seats unlocks a lot of opportunity aerodynamically. It also means we cut the part count of Cybercab down by a substantial margin. We're going to be delivering a car that has roughly half the parts of Fall 3 today. It also means when you need to clean the car as a rideshare asset, you really don't have to worry about navigating multiple doors, multiple seats. You really just have what looks like a bench seat, easy to clean automatically.
Okay, so I'm going to pause it there. That whole video was taken by Brian. He was physically there. You did a fantastic job, Brian. I've not seen other people do such a complete video. If you want to watch that whole video, go to his channel, Futuraza, and watch the whole thing. It's worth listening directly from a Tesla engineer. What we're going to do today, though, is I'm going to ask Brian all sorts of questions. We're going to get all of this answered. So one of the things he did say right there was that it's going to be half the parts of the Model 3, Brian. Maybe we could start with that. And then, of course, the big question is, you confirmed that there won't be a human-driven version of this. Start with that. Yep.
Sure. Well, on the parts count, that's critical. If you're going to be making something in high volume, you want it to be simple, you want it to be easy, you want it to be quick. If you look at the original Model 3, they wanted to do the whole line with just robots. But the problem is they were trying to apply modern solutions to old problems, and things like the fishing wires through the dash, that's a human kind of operation. Getting the insulation batting in, that requires dexterity that machines just didn't have. So what are we going to do about that? We're going to design it to not need those things from the get-go. The 48-volt architecture means the wiring harness is very easy to manage. The connections are all there. And we're not going to have wires going to every last bit of the car. We're going to have as few wires as possible, and we won't need them. So it's going to be designed from the ground up to manage that. When you look at the parts count, the original Model 3 had 380 pieces that went into the body, just the body. The structural Model Y got that down to 180, and the Cybercab gets it down to 80. Wow. And if you look at the interior, there's not a lot of pieces in there. So once you get those 80, then of course you have to do all the other things to finish the car. You've got to add all the elements to the body, but it will absolutely cut the parts count in half. I said the sound system, the cabin is so much smaller, you could cut the sound system in half. He said, we did. It is literally cut in half, and it sounds better because the space is smaller. When it comes to even the heating and cooling system, the thermal management, it's a smaller cabin to regulate. You don't have as much glass, so you're not getting a lot of sun rays to heat the cabin. It's not wicking heat out through the top to make it cold. We don't have to control the climate as much. So everything in every way has been addressed in that regard. Now, how do we know this will not just get a steering wheel and pedals and become human driven? Because it would be a different car. We know because that question was asked by me and by others, and every time the answer was the same: this ain't it. Someone then asked, well, but Elon said there'll be a $25,000 car. And he said, yeah, there's a lot of ways to get a car to $25,000, but this one isn't it. And if you look at when you're tailoring it just for autonomous driving, the requirements are different. If I want to make a compact car, a Smart 4.2 or a Mini, I still need to make it capable of doing everything a human driver would do to it, which means sometimes going 100, 120 miles an hour. It means multiple 0 to 60s just for fun. A robot will not do that. A robot, you don't want a car like this to throw you around in corners. If you don't need incredible cornering, your suspension gets cheaper. Your wheels and tires and brakes get cheaper. If you're not going to go over 85 miles an hour, you don't need an engine that's geared to 110, 120, or a motor, I guess I should say. So, and then you think, well, wait a minute. If I don't need to do all that performance stuff, that means I don't need a cooling system capable of keeping the motors regulated up in those extreme situations. I can scale down the entire cooling loop. Oh, but only if the cabin is small enough that it would still be adequate. The cabin is small enough. So if you wanted to make this human driven, you would need different motor, different cooling system. At that point, you then need different tires, wheels, and suspension, different brakes. And then at that point, you're going to need a bigger battery, which makes it heavier still, which means you've got to go back and rethink all those other elements. What you'd have is a different car, and we'd call that the NV91, which was canceled in April. So could it be built? Yes. And it was going to be built, but it was canceled in April.
Oh my gosh. Okay. Thank you, Brian. It's two really big questions here. So much to go all over the place here, but you have answered the question that everybody's been asking, right? Is this going to be just slop on a joystick, put on a steering wheel, pedals, and you're good to go? And you've figured out that no, it isn't, because when you asked all these engineers these questions, they actually told you, no, this is robotaxi first design. And your four videos that you posted on YouTube basically lists out everything that they made design decisions on so that it's specifically for robotaxi. So one thing that really popped out for me was when you confirmed, talking to these engineers, that they designed this Cybercab to be almost 100% factory, like robotic factory built, like less human involvement. Can you speak a little bit to that?
Yes. So that was something, what I did is I asked each of the engineers separately, what is the most exciting thing to you about this thing that you have built? And most of them said the efficiency. And then I got a couple of other answers, but one of them was that this can be built entirely by robots, no humans involved. The entire assembly line is going to be designed not for Optimus. If Optimus is needed, then you'd probably need a human. But it can be built by just existing robots. No miracle tech, no magic breakthrough, no step change in the way we think about a factory. Just with industrial robots, this car should be entirely buildable in that regard. So that means the lockout cages, where you've got these lockout zones where no humans are allowed, can now be the entire factory floor. So which reduces the amount of space you need. One question that was asked is this going to have a single body casting, a giant casting for the entire body that everything just gets bolted onto? And the answer was no, because that would defeat the unboxed method. It'll have a semi-structural battery pack, a casting in the front. There was some confusion as to whether there would be a casting in the back because there's not as much weight there and it doesn't necessarily need it and it's so small. If there is, it would be a much smaller casting. But the idea is that in a factory right now, you have stations. The body goes in and then it gets the doors and then it gets whatever. At each station has a specific size. And right now at a Ford or Volkswagen plant, the station size is 1.5 cars-ish. It's at least a car length. But if you're building it in modules, each station is only the size of each module. So all that extra space that you're not using at your station, you don't need. You don't need it until the car is mostly put together. It shrinks the entire factory, which is what we saw at Investor Day, that it'll be at least a 40% reduction in the total footprint of the factory. And that's before you even factor in how much faster this factory can actually move. So there's a lot of things there. I did want to mention on the speed limit, because you'd asked that before and I forgot to mention this. I said, well, if it's only going to be robot driven, you only need to gear it to the highest speed limit in the country. And I said, I think that's probably the San Antonio Expressway in Texas. And I said, I think the speed limit there is 85. And then I paused and said, is it 80 or 85? And the engineer said, it's 85.
Yeah. Okay. That was a very important point that you found out, right? Which is, this is the kind of stuff that people haven't really thought through. If you're creating a robotaxi first design vehicle, and I think you also confirmed that they said that it's mostly going to be city driving. So it's going to be slower driving. And you don't need, if you're just going to be focusing on slow driving, maximum is the speed limit. Then you go, okay, what is the high speed limit? It'll never go above 85. Everything changes, right? Like the size of the battery, the suspension, the shocks, lighter wheels, all that. You even worked out exactly why they chose the size of the wheel the way they did. And it's 1,000 pounds lighter than the Model 3.
Correct.
And then the other thing that was just little tiny things, like, can you speak a little bit to the interior, which is like they removed all switches? I think I wrote down from your videos, you talked about how normally there's nine
pieces of glass. So
yeah, okay.
There's nine pieces of glass in a normal Tesla. This has 3, the side windows and the windshield. A normal Tesla has a lot of buttons, but this will have just 5 buttons for the entire car. Window switches, door releases, and the rear hatch is actuated. It's motored. And there's a reason for all of them. They really wanted to get rid of the window switches, but NHTSA requires physical window switches. The door release, of course, you need those. Now, you know from having ridden in one that you don't actually need one, because when you take off the seatbelt at your destination, it opens the door. So that'll be something that you don't need, but it is there. And if you need to override the release, with a newer Tesla, it's got a setting to look at the blind spot. And if you hit the door open button, if somebody's coming up through your blind spot, it won't open the door. It'll give you a message on the screen that flashes and says, someone's in your blind spot. If you want to override it, press it again. So if there's an emergency or a false alarm, you just poke the button twice and it opens. This would do the same thing. And for the rear hatch, the reason they have a button at all, I thought, well, why even put a motor back there? That seems counterintuitive. The answer to that is, it's a flimsy piece of material. It's very lightweight, in this case, carbon fiber.
I'm going to get there right now. So you have a video here of the rear hatch. And so first of all, the decision here was to not have glass. Mm-hmm. And then you explained that the reason why they chose to not have glass is that it actually it affects everything. It's heavier. It's more expensive. Where is it now?
It attracts fingerprints.
And climate, right? Because now you have to deal with the cold. So all that makes a difference. So here, the rear hatch there, right there. So you said that that's designed this way because it's not, yeah, you explain it.
Sure. Normally on a piece of, on a hatch like this, it would be a steel outer skin with a steel inner skin that it's bonded to, probably welded, that holds the shape so it doesn't distort, because sheet metal would distort. In this case, it's carbon fiber, although in the final it may be plastic, it may be aluminum. They haven't quite settled on the skin just yet, with a molded plastic interior that is molded right onto it. That whole hatch probably only weighs about 8 pounds. So if you and I, as taxi customers, are going to be using this, we'd slam it. People slam it. That's what they do. Yeah. It would not survive. So instead, it closes itself. Let me do it. I got this. I'll just actuate it shut. So that's, and there is a button to open and close it. So that's great. And I imagine you can just throw stuff in, not even close it, and get in the car, and it'll close it before it gets in motion. So they've thought of absolutely everything.
Okay. So let's get to the doors. I am one of those people that was shocked that they went with this model. They call this a butterfly model, for a number of reasons, right? Like, it's just weird that they went with this model, right? People think it's too high, it's too wide, won't go into my garage, all those things. It's ridiculous. And then the engineer there on that, that the event that you were at, he explained that the reason they did this was because of ingress and egress. They'd be able to get in and out easier. Can you explain why they chose this? And I think you discovered that actually the height and the width I think this is the big discovery, or what you explained, is not as wide and high as everybody thinks.
Right. It looks high in my videos because I'm quite short. But if you look at the height, it's not unreasonable. If you look at the width, the vehicle is 200 millimeters narrower than a Model S. So this door all the way open is only as wide as a Model S with the door halfway open. That right there tells you most of what you need to know. But, well, my garage is really tight. I can't deal with this. Well, great. Why are you parking your car? Why don't you get out where it's convenient and let your car deal with that? You don't need to worry about how narrow and tight a parking spot is. If you're not getting in and out of the car in your parking spot, why would you get in and out at the parking spot? Let the car do that. So this can make it so that we rethink what a parking lot is. A parking lot won't need lines if all the cars are robotaxis. They can park themselves in the most efficient, most effective way for their uses. So there's, and the door being huge like that makes it very easy to get in and out. And if you do show the side again, you'll see that it's kind of a bench seat. The seats are very comfortable, but it is not buckets. It is a bench. I don't know about you, but in taxis, it is very common for me and my buddy to hop in the back seat and slide over. I don't want to walk around into traffic in a busy city that I don't know. I'll slide across. And in this, you can slide across. Well, I don't want to slide across. Great, then walk around. It's really not that complicated. But a lot of the concerns about the door safety and the door issues was answered just by seeing it in person. And I asked a lot of people what they thought of it, and they said, oh yeah, a lot of my concerns about the size or shape or whatever have been allayed by seeing it. And The reason, and I've had people say, well, they could make it so that it opens like this one. And then they'll show me concept cars that have had really exciting, interesting doors that open in strange ways. But this has a single pivot point. Unlike the Falcon Wing door, which has 4 hinges on each door, this has one pivot point. That means it's consistent, it's simple, it's reliable, it's robust, and you can control that. The last thing you would want is a fickle, finicky door breaking down out in the fleet. That'd be a nightmare.
Oh gosh, there's so much to go. Thank you for that. Okay, so the car was designed to be shorter and narrower. And so that's why the width of the door opening is not as wide as everybody thinks. And even the height, it's not as high because it's so low in the ground. But so everything was designed specifically for robotaxi. A lot to talk about the tires, but let's get to the batteries. So one of the questions you asked them was, what about the batteries? Is there a very specific battery? Which chemistries? And where is it going to be built? And they said it's battery agnostic, and therefore it can be built anywhere, depending on whatever battery that specific region is required, right? Can you explain that?
Sure. I don't know if they're allowed to answer direct battery questions, because I heard people ask direct battery questions and get kind of the runaround. So what I said is, where's this going to be built? In one place or globally? And they said, it will be built globally. And I said, oh, well, that means if you're building it in China, you're going to have to use LFPs. And if you build it in Europe, you're going to be using probably LG 2170s. And they go, yeah, it can use any kind of battery. It doesn't matter which kind. And so the answer becomes, it can, yeah, it's battery agnostic. The battery pack is semi-structural rather than a full structural battery pack, but the car is light enough that it doesn't need as much structure as even a Model 3. So they are, and the beauty of being battery agnostic is that you can, wherever you can get cells, you can build the car. And that means the version built in China would have either a greater margin or a lower price point, or both. So, yeah.
Thank you for that. That's big news. Again, just battery agnostic, and which is brilliant, because obviously they what's going to happen to batteries over time. And then the IRAs, those kind of incentives, it's based on batteries. You got to be able to switch that out. But this will be designed in multiple factories globally. And right now, I think it's one Model 3 can be, coming out of the Shanghai Gigafactory every 28 seconds. This could be half that if there's no human involved, if the parts are so much less, if it's 1,000 pounds, all that, right? What's your guess on how many Cybercabs they'll be able to produce?
As endless. You and I had broken down the numbers probably a year ago now, and we figured 2 million for a factory was probably the floor. And I support that. I'm still saying that. Unlike something like the Semi, which needs, 800 kilowatt hours per vehicle more, then there could be a bottleneck on batteries. The Semi can't realistically use most LFP batteries just yet due to power density. This can use anything. So I can't see any bottlenecks. I can't see what would slow it down other than maybe they would have to give a year's notice to ramp up production of the self-driving chips. But I think with a year's notice, they could get as many as they need to fill those orders. So this could be built. We've seen preliminary permits for Berlin to expand, to build something like this. Shanghai, we haven't seen permits, but we don't usually see permits out of China. They could absolutely get a factory like this going in China inside a year. So as soon as the AI team says this is solved, they will begin switching on our Model 3s and Ys on the network to gather preliminary logistics and start putting the factory together. And it's going to happen fast.
Okay, Brian, we're going to play a game. You love games.
I love them.
All right. I'm going to ask you rapid fire, at least 20 things that they did that made this car efficiency and designed for a robotaxi. Okay, go for it. I'll count as you go.
Oh, wow. 20. It doesn't need to do lateral sway in tight corners. So all of the suspension elements are cheaper. The rear wheels are larger than the front wheels because of aerodynamics. The front wheels have to be smaller because the aero drag in the front is worse. The back is teardrop shaped. The roof is not glass. The wiring harness is substantially smaller. There are no side mirrors, which would induce drag and make cabin noise. Where do we go? The cooling system is smaller. The heating requirements are less. The sound system's cut in half. The body panels are almost likely going to be plastic. Paint is expensive, they agreed. The motor is probably going to be the one that we heard about on Investor Day that does not use rare earth elements. I don't know. What am I up to?
You're 7. 7 more to go. You're 13.
7 more to go. Let's see here. Oh, you don't need speed rated tires. You could go with like NP or Q rated tires instead of the racing ones. What else? Let's see. Oh, it's lower to the ground, which reduces drag.
Switches?
Oh, yeah. Reduced switches means the wiring harness is smaller. 48 volt means less copper is being used. Lack of paint, I think I already said. I don't know if you counted that one. I don't know. I mean, that's like 15.
You got 2 more to go.
2 more. I can do it. I can do it. Let's see. Oh, inductive charging means they can charge themselves instead of having to rely on a human to oil up the Tin Man. And let's see, one more. The rear compartment is straight. Instead of being molded to maximize space, it is straight to minimize strain and reduce manufacturing complexity. 20.
Brian, you're the best. You're the best. You are by far the only person that knows the Cybercab so well.
Well, and if that isn't enough answers, there is the Ask Me Anything coming up on my channel, which will be on X and YouTube at 12:30 Pacific today.
Yeah, today's Wednesday, noon Pacific. Go on to Future Az's website or YouTube channel, and he's going to answer more questions. There's just so many things to cover. Was there anything else that I'm missing that I thought was important?
Front wheel drive.
Yes.
Front wheel drive, no frunk. They didn't want a frunk anyway, so the front end can be smaller. And you know what? We might as well put the motor there.
So the motor's in the front. Is that new? Is that something that they don't do
didn't
anywhere
know.
else?
Well, no. Tesla has rear wheel drive and all wheel drive cars. This will be their first front wheel drive car.
Wow. Okay. See, that's new. And the reason they did that was because what's the reason? Because they wanted to. The only reason you explained too. The only reason they even have a front on this car is because of safety. It gives that crumple zone, right?
Yes,
exactly.
exactly.
And that's all the front is. It's not even a frunk anymore. It becomes just all crumple zone.
And since we don't want a frunk, because that was another efficiency I could have named, is there's no hood latch, right. There's no hood actuator, there's no mechanisms for opening it. That cuts more weight still. It means you don't have to run power to a frunk light. It's little savings like that. And because you've got that space, you might as well put the motor there and leave the back wide open.
Leave the back. I see. That's how they have such a huge trunk in the first place. So to be able to fit. Can you tell me all the things it can fit? He said, did he say like a wheelchair, 2 luggages, bikes?
Yes, a bike if you take the front wheel off, as many people do, and golf bags, 2, 3, 4 golf bags. Yeah, it'll fit. I've been asked if it would fit a surfboard. I don't know. I don't know how big a surfboard is, but but if you told me, I still wouldn't know.
All right, Brian, that was amazing. In manufacturing, you said that teardrop for efficiency. What does that mean? The front wheel is smaller than the back wheel.
The back end is a little skinnier than the front end. Ideally, for aerodynamics, you want a long, skinny vehicle that is tapered in at the back. So it's like a raindrop falling.
Oh, so the back end is thinner, but there's no B pillar, no glass. 3 pieces of glass total. So then therefore, what does that do if there's no B-pillar? Just another thing to make it easier to manufacture?
Yes, B-pillars are expensive. And instead what they've got is a rigid wall behind the passengers so that luggage doesn't come forward in a crash, and that can now substitute as what would have been the B-pillar. And now you're not constrained by where you would need a B-pillar, so you can make the door bigger.
Okay.
You're getting all the wisdom, Herbert.
Oh, I'm still trying to drill for more, but no, I think we're good here. This was fantastic. Tune in to his channel at 12 noon or 12:30.
Noon 30 today Pacific. Yes.
Noon 30, 12:30 Pacific time. He's going to answer even more questions. We covered a lot, but there's just so many things that you did. Just the details that was important. I think the big ones that you basically figured out that everybody were still debating was whether or not this car, it can become a human drivable version of it, and it's good to go. It's going to be the $25,000 car. And what you've learned and everything that you've listed out is it is so specifically designed for robotaxi, so specifically designed for that it's at this point very unlikely that they'll just slap on wheels and they can't. They really can't. There's no rear window defogger. There's no rear window, right? They don't have a side mirrors. They don't have all these switches that they've removed. It's a totally different car by the time you have to bring it back, right? So I think that's a big one. And the fact that is it all 100% robot built? Like they don't need humans.
That is the
to build
plan.
this?
That is
100%?
the plan at this point. Yes, beginning to end, that is the plan.
And that's part of what they did. And so that would just be unbelievable how cost effective this will be and how efficient it is. Everything from the tires to beyond. You just covered so much. So check out his channel and watch his videos like I did. And they are just unbelievable, like tiny little details that you've unearthed about this. Thank you so much, Brian. Follow him on his YouTube channel, Future Awesome. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.